Happy AI Infra Day! Welcome everyone. Good morning. I'm happy to kick this session off. Welcome to Women in AI Breakfast of AI Infra Summit 2025.
This isn't just about breakfast, it's about the space to connect with others who are actively shaping the future of AI infrastructure, right? So take this time to connect with others, share what you're working on, and explore how you can support each other and as the ecosystem grows. Let's build this ecosystem together.
Lauren, CMO, is going to be the moderator of the session. Thank you everyone for coming. I'm looking forward to having a great day with all of you together. Thank you.
Hey everybody, welcome to the AI INFRA Summit. This is the Women in AI panel. I'm so excited to be here with you all. So I'm Lauren Vaccarello. I'm the Chief Marketing Officer at WEKA. So I'll be your host today. This will be the only time I talk about myself. So for those of you who aren't familiar with WEKA, we are an AI infrastructure solution built for AI in your most intensive workloads. So we're not just traditional storage. We are a software-defined platform designed to handle the most challenging workloads in whether it's RAG, inferencing, training large-scale models. We can do it all. We will eliminate your data bottlenecks and deliver fast, consistent performance. So a little bit about what we can deliver. We'll increase your time to first token by 40x. We've helped companies like Stability AI get up to a 93% GPU utilization. I know those are some of your most expensive resources. So for companies like Stability, we've 3x their GPU utilization. We've also had a 35% improvement in model training time for them, all while reducing their cost per terabyte by 95%, which saves them like $1 million a year in storage, which is pretty solid. So what we do is we deliver speed and ROI, helping teams get the most out of their GPUs and reduce time to results and accelerate the time to market. So that is enough about me and about WEKA. I want to introduce our absolutely incredible panelists. For those of you who don't know, I'm going to get mine. So first up, we have Jessica Audette. She's the head of research technology management at Memorial Sloan Kettering. Jess is incredibly accomplished. I'm actually going to read her bio so I don't miss all the great stuff she does. So she oversees technical strategy to drive initiatives that advance cutting-edge cancer research in healthcare. She formerly served as the head of HPC at Memorial Sloan Kettering, and under her leadership, the implementation of an IO 500 supercomputer, Iris, ranked number 2 in the U.S. and number 4 globally. She significantly accelerated data analysis and scientific discovery, improving the speed and precision of groundbreaking medical research. Her work empowers researchers with the technology they need to make vital advancements in healthcare, pushing the boundaries of healthcare innovation from cancer genomics to personalized treatments. You are in for a treat. And then we have Sonam Kanungo, data engineering leader at Crusoe. So Sonam leads innovative data engineering projects that support Crusoe's mission to align technology with climate goals. Her team operates horizontally, supporting all functions and operations at Crusoe AI. She's passionate about data-driven decision-making and enabling Crusoe to become the world's favorite climate-aligned AI cloud. Before she joined Crusoe, she worked at Netflix, Mercedes-Benz Research and Development, and Verizon, gaining extensive experience in building and optimizing data platforms. Thank you both for being here and joining us. So, for those of you who don't realize this, these are the women who are fundamentally changing the world with AI. And to change the world, you have to be prescient about the future. And that's something I've loved getting to know the two of you about how you were thinking about the future and how the decisions you've made today not just help what your companies are building today, they help what you're building tomorrow. So like I said, these are the women changing the world in AI. And you are in the right place today. This is going to be the best panel you've had the entire day. And
yeah.
So we did a prep call. We had all the official questions. It was really good. And then during the course of the press call, both Jess and Sonam said things to me that completely blew my mind, and I hope it is going to blow yours the same way that it did. So, without further ado, we're going to kick this off. Jess, we're going to get started with you. So, I don't want to steal any of your thunder, but I want you to share your story about innovation and impact that your team at MSK Cancer Center delivers. And the impact your team has done. You told me the story about the impact your team has had on colorectal cancer.
Yes. So the team that I work with and work for and support is research technology management, or research technology services. So our team is dedicated to empowering the researchers of Memorial Sloan Kettering Cancer Center. And that's not just on the basic science side. And we have researchers that are scaling all the way up to clinical. And as Lauren alluded to, we recently had a clinical trial that had 100% success rate in colorectal cancer trial. So all 42 patients are in remission.
Yay!
The vast majority of that work and the research was done on our clusters, albeit the legacy ones, and now we're improving and we've developed this new supercomputer called Iris, which is the cluster discovery. It's outputting 3 times the performance and turnaround times for our researchers, which means that they get to their results that much faster, which really enhances their time to market, which would be to patients ultimately. So whether it be drug discovery, patient care plans, early detection, that you name it, they're doing it on our clusters. So it's really inspiring to see, albeit a degree separated from the patients, that we have this type of impact on the world.
And do you think you would be able to deliver that scale of result if it wasn't for AI?
No, I don't. I think that, no, I don't, honestly. I think a lot of what the researchers are doing is it's groundbreaking because they have these brilliant ideas of things that they could be doing, and it seems silly that we're the people. I'd like to call us the odds behind the curtain. They're out front paving the way, and we're just pulling the mechanisms in the background for them to be able to do the work that they can. And that's really the infrastructure, and that's what we're supporting them with. So without that, they couldn't do the work that they have today.
That is incredible. And for anyone who missed that, Jess and the team that she enables had 100% success rate in curing cancer. There's a lot more I want to dig in there, but I want to put pin on it for a second. So we've all heard about how power hungry AI is. We hear about this all the time, and we've heard that data center electricity usage is projected to more than double by 2030. So you hear all these stories about how AI is going to accelerate climate change, and maybe AI can figure out how to solve climate change before it tips us over to the 1.5 degrees Celsius. But does it have to be that way? Does it have to be this paradigm of the power-hungry AI usage, or is there a better way to do this?
There's a better way to do this. I feel like AI is there for the betterment of humanity, but it requires the power and the energy that it needs. The approach that Crusoe has taken is find these standard renewable sources of energy and move your data center over here. So we want to go and with these clean sources of energy which are environmentally aligned, and this is the principle that we follow. This is from where we start building. And if this is the way that we can operate AI, by sourcing the energy from clean sources, and there's nothing that we need to worry about 2030 and whatnot. And that's the principle that we want to go by. And if we go that route, we so feel that the AI is not a threat, it is actually a service to humanity.
Absolutely. So I want to talk about some of the challenges you're facing with clean energy. So for something like solar energy, sun's only out for half the day. With wind power, it's not windy all the time. So what do you do and how do you start thinking about things like load balancing?
Yeah. So the challenge with these renewable sources of energy is that they are not as consistent as grid power. And the way that approaches that if we can't do 100%, then we get some more from grid or from a secondary form of renewable energy. We have our data center in Iceland, which is like geothermal, which is 100% renewable. So we adopt an approach where even if we don't have a perfect solution, having a 50% solution, which is like a renewable source of solar or wind, we are fine with that for now.
So it sounds like your approach at Crusoe isn't just this traditional approach of let's just plug into the grid. You are fundamentally reimagining how you can actually run data centers and how you are able to deliver performance for your customers.
Start from somewhere.
Absolutely. And it's what I love that both of you are doing is there's all this in the media about here's the terrible things with AI, and this is how it's going to be Terminator coming and taking over the world. But what both of you are doing, you're actually using AI to change the world for the better, to make faster advancements, and to do it in this renewable and sustainable way. And again, I hope you all realize why I was so thrilled to have both of these people on the panel today. So I want to transition a little bit into how we do this. So Jess, cancer research seems to be a slow-moving process. What about this process? What technology have you deployed? What changes have you made to start to speed this up?
So we've made a lot of changes to our ecosystem for our cluster. We moved away from some of the aging technologies, and our chief architect has really made it his goal to identify things that will support our researchers' needs. So we have a team of folks, we love to call them our research solution engineers. They have a computer science background as well as a background in science, some domain. They work closely with our researchers to really understand the needs of from the science to the technology, and they're able to translate the science requirements into a technological solution. So I think that that really enabled us to make the decisions towards our biggest cluster, which we have seen outstanding results from already. And the demand from our researchers to get on our new cluster has been a bit of a clamoring as well. I'm sure everyone's run into this situation where you have folks that are using code that's about 20 years old and trying to take them from one type of scheduler or one type of file system and then transition them into something new is a burden in and of itself. So our research solution engineers are working diligently on improving their workflows and enhancing their code to essentially turn their results around for the betterment of their research. I mean, there's oftentimes that our researchers are up against grant deadlines or federal requirements or compliance requirements to turn around some sort of results. And so the clock is always ticking. And these days, it's not just first to publication anymore, it's first to discovery. So giving them the fastest and best technology out there, the most cutting edge infrastructure available to them at the moment is really key. That's what our team really focuses on offering. So I can't lay claim to making the decisions at all. I hold that all to the chief architect and the architects of the RTS team. They are brilliant technologists who are really keeping an eye on the forefront, attending sessions such as this and other conferences, collaborating with other well-known institutions to see what's going well, what's not going well, and how we can support our researchers in the same manner. So I like to think that we're at the forefront of that, and people are looking to us now. But we'll see how that goes.
Didn't you just your cluster have a benchmark result of the second fastest cluster in the United States?
Yes. So we recently attended the supercomputing conference in November, where we attained with WEKA, the only one on the list for the IO 500. Number 2 globally, and we're just behind the national lab, and number 2 nationally, and number 4 globally, which actually, if you knew our results from last year, we were number 5 globally, but our results were double what we had last year. So that just goes to show the type of infrastructure we're putting in place. With our resubmission, we doubled our results from last year, which is outstanding.
That's pretty incredible. And then what, because you're able to double results and because you're able to improve speed so much, what's the impact on the researchers?
It's huge. And I have two different examples that I'd love to share with you all today. The first is we have researchers that are, as I mentioned, doing basic science, de-identified patient data, and scaling all the way up to the clinical. And I like to use this example because my mom was one of them. My mom had a very rare type of cancer. It's called mucosal melanoma. Traditionally, when you hear melanoma, you think of skin cancer, but this one was in her sinuses. And at the time, when you find something of that nature, it's metastasized everywhere. So spleen, brains, spine, kidneys, lungs, it was everywhere. And what our basic science lab is doing is they are working towards identifying, using AI, identifying where that metastasized cancer is. And they're sharing those results with the clinicians so that they can make informed patient decisions on treatment plans. So, for example, in my mom's case, the fact that we found out where the metastasis cancer started, we were able to do treatment directly on that, as opposed to, going after all of these little things which will ultimately deteriorate your health. So that is a really outstanding example in use of our AI cluster right now and how that's scaling just from basic science all the way up to patient touching. And the other one that I like to use and is something that really resonates for those of us that are perpetual students is we have a PhD doctorate who moved his work from our legacy clusters into our newest supercomputer. And he was able to attain his PhD a year in advance because the results that turned around from our cluster made it so that he could complete his work. And to me, what that says is he now needs to focus on his studies and now gets to take all of his attention towards finding cures, vaccinations, drug discoveries, treatment plans that much sooner. So I will take that. A year in advance means that it's a year faster that we're getting him to put his attention towards patient care. So it's outstanding what we're doing.
That's amazing.
Thank you. Thank you so much.
Thank you. And then, Sonam, I want to talk to you about some of the work Crusoe is doing and what you're able to deliver for your customers. And a lot of when I think about how you were scaling AI and you're supporting all of these customers, you must run into different bottlenecks. Are there hidden bottlenecks that you found when it comes to compute, networking, infrastructure, and then how do you overcome some of these challenges?
I think one of the challenges that we face is speed. The speed that we want to build our data center, the speed at which we want to deliver the GPUs to our customer. And what we are great at is building our most recent data center, which is like we built in Texas. That is being built at a speed that I myself was surprised. We had nothing on the ground last summer, and right now the data center is up and ready to start working. So I think the challenge of speed is what was the most difficult one, and I think we've done a good job at solving that. That's one aspect of it. The second aspect of it is building the data center and keeping everything sustained, right? That's another challenge. So what we do is, or what we want to do is keep all of these things abstracted from our customer. We don't want our customer to know that there is a fluctuation in the grid power on our side, and that's why they can't do it. So this layer of abstraction is also something which is challenging for us to maintain, but we are doing a good job at that, I think.
And you've got 99% uptime, 99.99. I remember reading this and talking to you about this.
Yes, we have 99% uptime. Our customer support team is available. We follow the sun with our SRE team, and it's going great.
Right, and it's his ability to deliver these incredible results for your clients without compromising on in terms of sort of sustainability is pretty incredible. And when you think about where you need to be and where Crusoe needs to be in 2 years and 5 years with AI, what are you thinking about and how are you building for the future?
Yeah, I think what we are doing is we are finding these standard sources of energy, which is the hydrothermal plant, which was not in function, like few years ago. And what we are trying to do is we are trying to work with the local policymakers and like local government, and what we are trying to do is making that in function so that that becomes source of energy and that also creates some environment in that local area. So while we keep looking for these better sources of energy, we also want to improve the local community, the local labor market that is there. Uh, and that is exactly what we want to do going forward. Like, the another 5 years, we want to follow the same principle and then scale following these principles is the follow one.
And I know your company is growing really rapidly. How do you think about scaling your AI engineering teams to build, again, not just for today, because we know how quickly today is going to be gone for tomorrow as well?
Yeah, I think we hire really talented people, but I don't think we hire for specific skill set that we want. We hire people who can learn quickly and who can iterate fast. Because with things that are changing in the AI world, you never know what skill would you need for this engineer. So we look for like talented people rather than specific skill set.
Uh, One more question on that is just what advice would you give your people here about as they're going through the same things, as they're hiring talent, as they're building a long-term team structure? What advice would you have for people here?
Yeah, I think need to be a student for life. That's what the reality is. I think going forward, there is no doubt that the work places are going to change. People like teams are going to become more lean and more efficient, and that's why the skill to be able to learn new things is great. And it's like one of the advice that I have for like anybody is being able to read the code really fast. I think there's nothing that can beat that skill because if you are not the one who is writing the code, you'll still be the one who's reading the code. So that's a great skill.
And Jess, I want to talk to you a little bit more about just the scale of data that you have. Right now, I know you've got more than 50 petabytes of data growing. It's rapidly. We just had another 8 petabytes yesterday. So, sorry, we had 8 petabytes of data yesterday. No big deal. So what steps are you doing to make sure you have the right infrastructure for not just 2 days ago it's 50 petabytes, today it's 58 petabytes, next week's 100 petabytes.
Yeah, I mean, I can't say we at MSK have all of the answers because we certainly don't. We're still trying to figure out our data consumption rate and what to do with all the data. I mean, in the healthcare industry, there are a lot of compliance restrictions and grant restrictions that we must retain data for, anywhere between 3 and 20 years, depending on whatever the client named and such. So for us scaling, I have to agree with speed. We have to keep up with the demand and then also identify applications or solutions that can help us with tiering, auto tiering. So we're looking into a couple of things that might be able to show us if there's something that hasn't been touched in X amount of days, could we move that to cold storage or archival, or we're investigating cloud solutions if there's something that can support our needs there. I mean, I don't think there's ever going to be a time where HPC is fully in the cloud, but there may be some solutions. I think cloud or cloud makes sense would be what I would put for our team. So I think, like back to those research solution engineers, they're also working closely with our researchers to have an understanding of their future needs, which really empowers me and my team to figure out, okay, what are we going to need for future state? So if we're at 50 petabytes now and 50 plus now, and my RSCs are coming back to me and I'm pulled together a growth chart to show the demand of what they're expecting from scale. And that's just based off of new folks joining the organization. Our team onboarded 16 new instruments in Q1 of this year, which equates to about 5 instruments a month, which if you're turning that around and it's writing directly to the storage, that's a huge boom in our storage demand. So the growth chart right now shows that our customers, our researchers are requesting double of what we have this year. So I don't know that's not a decision I'll be able to make. That's definitely above my pay grade leadership decision. But what I can do is really bring the story to life for our leadership to have an understanding of what we would not be able to provide if we didn't have that type of storage and what's available to them. So we don't have all the answers, that's for certain, but we're working on that.
And you had mentioned something about you don't think you're in a place where you're going to be able to do everything in the cloud. Tell us a little bit about where you are right now from an infrastructure. Are you in the cloud? Are you in a data center?
We're largely on-prem. I think if our researchers, and I'm sure many of you out here have experienced it, if our researchers could hug the server, they would. I have to put the fear of God into them sometimes, where my first year at MSK, a dry lab happened to be sitting beneath a wet lab, and that wet lab flooded on top of the dry lab. And that person had, mass storage just sitting underneath their desk, and 23 years of data gone. Research just gone. And there wasn't much we could do, but of course they came to us and they're like, hey, IT. And then we're like, did you try turning it off and turning it back on again? Didn't work. So I really encourage them to put their trust in us, where we have replication, we have backups, we're at, co-locations and sites that we own, and to put their trust in us and that we support them in that way. But our infrastructure is largely on-prem. We are looking into cloud bursting. We're looking into GPUs as a service for a particular project. As I mentioned, our researchers may have a deadline and they might make a great use case for spinning up a GPU cluster to have them run their work and then pull it back down. But I think one of the things that we've faced and that we're seeing, we are testing storage in the cloud, but egress charges. We have one of our core, our sequencing core has put some of their data in the cloud, and they're paying an astronomical amount of money right now to reserve it there. And it makes it really difficult to try to have more folks adopt cloud when they're seeing those prices, especially with the way the legislature and policy that's coming out of the White House right now. There's a lot more restrictions on grant funding, which means that their precious earned dollars, they're less inclined to spend on infrastructure as they are on postdocs that'll help them get their research further. And I don't blame them one bit. And so we are doing absolutely everything we can to support that and looking at all options for our researchers, for sure.
And then how important is it for you and your researchers to have that sort of flexibility and choice, not just sort of today, but also who knows what's going to happen in a year?
Yeah, I mean, obviously, we as humans want options. I mean, nobody walks in and says that's the only thing that's available to you, and you're like, I don't know if I want that. So we do try to share. I think it starts with education, because a lot of what our researchers think is like, it's like the cloud, like your phone, and it just pops up there and you can pull it back down and no big deal. But in this type of environment, there's a lot that in between work that goes on. There, it's not as self-service as that. So then we need additional personnel and manpower to help put things up and break it down, package them and such. So we're still investigating all avenues to support that. And there are some use cases that make for a great cloud use case, but largely we're on-prem, and I don't foresee that going much further away because, as I said, the researchers, if they could hug their servers, they would. I can show you some horror photos where we still have, I think they have like an industrial fan cooling their racks in the back of a lab with like all of their beakers and tubes. And I shared this with our VP of infrastructure, and he laughed, thought it was fake. And I was like, that's actually real life. So
We did not generate this.
it is not an AI generated photo. It's real life. Someone is actually putting an industrial fan on their racks to cool it in the back of their lab. So
It's not slightly concerning in any way, shape, or form.
no, but I did tell them if anything happens to please call the other IT teams, because I will not be available, and I will highlight out IT. Have you tried turning it off and turning it back on again? Okay, great. It didn't work. You'll have to call the help desk, and that will not be my area of expertise, because we have warned them, and I have warned many of our researchers, and lots of them are very keen to get into our cluster and clamoring to move over. I think I mentioned to you just in Q1, we've had an uptick of 33.6% new users to HPC at MSK as a whole. So these are folks that have maybe are net new to the organization, have never used HPC before. We're seeing a lot of folks that were basic science that never touch pointed on HPC, and now they are. And they're hiring computational biologists and technologists and such to help them with their work. But I think it's I know it's largely because the infrastructure that's available to them enables them to get their grant funding. And I think I've shared this metric previously, but our infrastructure enabled our researchers to bring in over $183 million in grant funding. And without that, and without that justification and sharing that with, the larger granting authorities like NIH, NSF, they wouldn't be able to have that funding available to them. So it's we're not actually doing all the work, but we certainly like to empower them to be able to do whatever work they can do.
What do you think the impact would be if money was an object and all of your researchers were able to get sort of full access? You can get as many clusters as you want. Like, what?
I still don't think that they would be satiated if we hadn't as much money as possible. They are going to get as much as they think they can. So in our case right now, we are migrating from legacy clusters that have cascade failures. We're migrating off of infrastructure that's no longer under warranty. It's a bit of a mess. We have metadata that's corrupted, and our team is working diligently to keep everything up and running whilst upscaling our newest cluster and as we move people over. But just to put it in perspective, amongst the 3 clusters last month, which we would have thought we would have seen a down skip on our legacy cluster usage, that wasn't actually the case. Between our 3 clusters, we had over 5 million jobs submitted in the last month. So I would have thought that they would have stopped using the old clusters, but it seems they'll take whatever resources they can get. So until we rip their access away, they'll be using whatever they can. So if money were no object, they would get absolutely their hands on everything they could, and I would empower them and support them to do that.
That is incredible, and it just shows that the level of impact that they're able to deliver. They'll take an imperfect solution in an old cluster because it's better than nothing.
It's better than nothing, for sure.
And so I want to sort of change topics a little bit and talk to you about with all the customers that you've had on Crusoe. What's this level of scale that they're working on? What are you able to help them deliver as well?
Yeah, I think as I'm saying earlier, our services are very good and the speed is a challenge for us. And maybe that's where we want to build our services the most. That we don't want them to worry about and whether we have some limited resources. We want them to come with anything that they need and be able to build on that. I can't give you the exact numbers. But it has never happened that your customer has come and you don't have the resources or the GPUs or anything else that they need.
And then I think a lot of people are always thinking about can I get access on GPUs right now, and it seems to be at such a premium. And it sounds like you're continuously able to deliver this for customers today, for customers tomorrow.
Yes. I think Crusoe is an AI first cloud, and the offering that we have, which is called Crusoe Cloud, is specifically built for AI. So it's very easy for somebody to come and understand all the tools that we have because it's a very nimble architecture which is built for AI. So you need not worry about these 36 other services which are being provided and you are unsure which one to pick, which way I should go. What we have is keeping our customer in mind. If a customer comes, this is the first thing that they should be looking at, and we have made it very simple. So the learning curve and this is what we have heard from a lot of our customers, that the learning curve is really less, and they come and they are able to get productive within days of signing up for our services. And that says something about how we have built and how we are so much customer related.
What were some of the biggest challenges or unexpected challenges you had as you were sort of building out a data center and building out a next generation infrastructure?
Yeah, some of the challenges were very were not something that we were anticipating. And when we started building it we really had to build a city which is supporting itself so as to house all the workforce that we have. And even in the future, when this data center will be operating, the city has transformed forever. It needs to support more number of people living there. And this was not something that we were anticipating or we never thought of this as a challenge.
And it's such an interesting because you wouldn't think about that. You wouldn't think about as you're building up data centers, AI is just sort of taking over the world. The fundamental impact it's going to have on place the data centers located and all of these things. I would never even thought of in the city even support this. Yeah. And it's a great impact on communities. It sounds like you've been able to create a lot of jobs in addition to, building this incredible infrastructure.
Yeah. And one thing that we do is that every place where we go and build a data center, we integrate well with the local communities and the local governing places, and we do everything so that we don't impact the way that people were living there. And like this data center does not impact the local community and people in any way negative. And that's something that we want to continue to do, not disturb what is already there. Don't break the system.
And then question for both of you. For people in this room are figuring out their infrastructure, figuring out what they want to do as they are building out to the scale that both of you have built out. What advice do you have as they are thinking, what do I need? How do I build an infrastructure for AI that is going to work today, that is going to work for 6 months from now, that's going to work for 5 years from now?
I think NVIDIA is coming up with new product every 100 days, right? And that's like, a new version of it, a higher speed of product. So you want to keep this thing in mind that what you're going to do with what you have in your hand. We say the product, which would be most popular product 3 years down the line, and now people are excited about something else. So instead of keep looking back what you have and making most out of your entire field of system is something which the infrastructure companies have to keep in mind.
Oh, I would definitely concur with that, but I also want to take a different viewpoint as well. So when you're considering to build out your infrastructure, oftentimes what I hear from folks is that they can't convey enough to their leadership how important it is. And sometimes we get too deep into the technical and we need to remember who our audience is. And so I often encourage folks to speak to your users and really understand what their needs are to create a solution for them. And when you have those stories and you're able to share those use cases with your leadership and show them what the outcome of the business outcome and the ROI might be, and what we would be lacking if we weren't able to invest in something like that, it seems that there is a more positive response for them to invest millions of dollars into infrastructure that's really critically needed. So I take a different view of the business need and sharing that what the outcomes could be to ensure that we can get what our teams will need for the future state.
And if they come back and say, that's great, can you do it for less? Can you get away? How do you think about utilization? How do you help convince them?
So that's where you can lean a little bit into the technical pieces there. It's showing them that the technology that you've chosen, the infrastructure that you've chosen is the best infrastructure for your use case. So that's where I'm leaning into the technical. And oftentimes, and I joke, I used to work for a CTO, and he'll laugh when he hears this, but I used to say he was the most brilliant man, but he couldn't figure out how to work his printer. And so when you bring something to someone like that, they do understand the technical, but you don't need to get so deep into the weeds with them. What they need is to be able to pitch it to their leadership and say, okay, they've done their research. They've looked at every offering out there. They've tested AMD, they've tested NVIDIA, they've tested the storage options out there. And that's really, they've chosen the best, and we're getting the best offer, and we've negotiated. And this is the option. These are the 3 options that we have available to us. And again, give them options, because no one likes to be told that this is the only one that they have. So that's really what I would do, honestly.
And if people in here are thinking about building it, to your point, do you have to get the newest, fanciest chip? Do you have to get Blackwell? Like, do you have to do these things? What can you do? Is there technology that you're like, maybe you can use last year's model of this, but you need that? Like, how do you think about building everything for the infrastructure?
Yeah. I think we have had customers who want to specifically want a certain type of GPU, but then we are considering another form of service, which is offering intelligence as a service, right? And which is like this layer of abstraction on top of our which we use, where you get the services through an API or through something else, and you need not to worry about any form of infrastructure. Don't need to worry about what GPUs are being used out there. Like you will get the best performance for the request that you are coming up with. So working with a different business model is how we are considering to solve this problem.
Benchmarking. A lot of people will think that they need the flashiest, biggest, best thing, and then you get their workload into the system and it flops. And it's not because it's not the best, biggest thing isn't the best thing. It's just not the best thing for their workflow. So benchmarking is critical. Our team supports a lot of our researchers in doing some of those things. And we've identified areas where, an A100 worked well for them as opposed to an 8640 or an 8690. It just depends on their needs. And we have a myriad of different types of GPUs available in our cluster because we're also servicing researchers that have varied demands. I mean, we have everything from sequencing to genomics to computational biology to radiology, pathology. They're not all wanting the same thing. And even within those departments, they don't need the same thing. So benchmarking is your best friend, and that'll really enable you to support that in their needs.
No, that's fantastic. Are there any tips for getting better benchmarking? Anything if I don't know how to do it myself, where should I go and look? I just copy what you did.
I'll give you my chief architect so we talk to him about the benchmarking because he does most of that for us. But I refuse to say his name anymore because he's become very popular. And we know coaching is a big deal these days for the skill sets. But I think the good thing about our community is that it is very niche and it's very small. So when you come to things like this and you network, you're able to meet other folks that are stumbling across very similar, albeit different, use cases and roadblocks, and you're able to connect with them and figure out what's best for you. So the network is really what's going to enable you to figure out, like, hey, I have this issue. Do you have that?
That's a great point. Good for everyone in this room to remember that this is your day. This is your day to meet with some of the brightest minds in AI infrastructure. Everyone here is looking to solve the same challenges. So spend time with each other, meet with as many people as possible, and see how we can help each other. I mean, fundamentally, we are not even the first hour of day one in what AI is doing. So we are learning this together and we're building this together. So final question for me, for both of you. I am so impressed with what both of you are building. You are driving these critical innovations in an extremely technical and complex environment. So what advice would you give to other people in this room and other women about how do you build an incredible career like you've had in AI and data infrastructure and fundamentally in engineering?
Yeah, I think baby steps. You need to keep on building your skill set. You need to keep doing that small thing because everything matters in the end. Uh, and plus, know where you are going. You need to know that, that's where I want to be 1 year down the line, and now we walk towards that goal. I think that's the approach I give.
I will try to be brief because I think and I was saying this earlier today, I feel like I was one of the women that was in this room. And I would raise my hand constantly and ask this question, how do I get to where you are? And no one could answer it other than saying, raise your hand. And it's like, well, I only have 2 hands. But my background, I didn't follow the traditional path to technology. My background was largely business. But I found that I was solving complex problems with data. And there were times that I would be I need to carve a space out for myself in a room where I was largely the only woman in there. And that really taught me to speak confidently and with clarity, even if I felt unsure of myself. And one of the things that I think as women inherently we do is we rely on the results of our work. We think if we work hard, we keep our head down and we just continue the path we're going forward and we raise both hands and say, I want to take on that and just keep going until they burn out. Is you think the results are going to speak for themselves and they're not. And that's where I think I tripped up in early on in my careers. I just thought I was great at doing what I was doing and it would speak for itself and I'd get that promo and I'd continue on the trajectory. And what I ultimately learned is that you need to be strategic about the opportunities that you are choosing. And you need to not only seek out mentors, you need to seek out sponsors as well. And what I mean, the difference between that is a mentor is someone that will coach you and work through things and, take it to the board and bounce ideas off with you and give you the hard truth when it's hard. But a sponsor is someone that will speak volumes about you when you're not at the table. And sometimes as women, we need an ally in the room, and it can be male or female. And that's when I look to some of our male allies and say, that's your opportunity to say, hey, she's kicking butt over here, and I love what she's doing, and I want to hear more about that. So, be strategic and remember that visibility matters, and you don't have to say yes to everything.
I think that is incredible advice. And then one sort of piece I'll add on to that is when you're in the room, be an advocate for other people. If you see great work that someone else on your team is doing, be the advocate, talk about this, and that'll help everybody else as well. And I want to thank everyone here for coming to the our breakfast this morning. I want to thank our incredible panelists. So was this a pretty solid way to start our day?
Yes.
Thank you, everybody, and to more AI and curing cancer sustainably. Thank you, everybody.